Hello everyone, welcome to Target45. Today we are solving problems based on conditional if and else. So there are few problems which will be helpful for multiple choice questions or like tricky logical questions. So this would be helpful in order to solve those problems. So let's solve today. If you still have not subscribed to Target45, please subscribe to Target45. So if you see, we are going to solve today even odd problem, leap year problem, as well as is deficit, abundant, is composite. In the same way, is a number hexagonal, triangular. So we are going to solve this kind of problems today. Um, so if you see here, this is a class where we have all the methods written, all are empty methods, and the execution starts here. We'll take the number from the user here, and this input function by default gives the output in string format. In order to get the number in the integer format, we are using int function and we are converting that into the integer, and then we are calling each method on the class like this. So let's solve one after the other. So first we'll solve the even odd problem. So even odd is very straightforward. If a number is divisible by 2, then it is a even, otherwise it's odd. So let's write a code for this. Number modulo division 2 0. Then we have to return number is even, else we have to return f strings number is odd. So in this way we have solved one problem, that is even else program. We have completed that. So next we'll solve leap year problem. So leap year has two conditions. You can call a year leap year when it satisfies two conditions. The first condition is if it is divisible by 4 and not divisible by 100. This is one condition. And the second condition is if it is divisible by 400, then it is a leap year. So let's write these two conditions. If year modulo division 4 equal 0 and year modulo division 100 not equal to 0, this is one condition. Either this has to be satisfied or year modulo division 400 equal to 0. Either this has to be satisfied. We'll have to return the year is a leap year. We'll use f strings. So we'll the year is a leap year. Otherwise, it's not a leap year. So, in this way, we have solved two programs. In this program, if you see, we are using and or. So, and means both of the conditions should be satisfied, or means either of these two conditions has to be satisfied. So, you have to remember this. These are simple programs, but having good understanding on the simple programs is also important. And this is using simple if else. And next up, we'll solve. We did not check the output. What we'll do is we'll first write the code for all and then we'll see the output of for each of the program. So now let's understand what is a deficit number. So deficit number is, if you have followed this coding series, yesterday we have covered perfect number. So we know that perfect number is something if a number is If a number's sum of the proper division is equal to the number itself, then it is a perfect number. But for deficit number, the only difference is the sum of its divisors has to be proper divisors sum has to be less than the number. Then it is a deficit number. If the sum of its divisors is greater than the number, then it is an abundant number, which we'll solve here, which is this. If you see here, there are two numbers 12 and 10, and the sum of its proper divisions is 16 here. So this is a abundant number. Whereas for 10, the sum is 8. So this is a deficit number. So we will code both here only in this program. So basically it is like if one condition is satisfied, in else we have to write the another condition. So we'll take the division sum. So we'll use sum function here. So I'll make it easy. For I in range 1 to number, we have to check if that number is divisible by I. If it is true, then we have to collect all such numbers, that is I, and we have to take the sum of it. So this line gives the sum of the divisors. It's not division, it's divisor. So if divisor underscore sum less than number, then we have to return deficit number. Otherwise, we have to return abundant number. So this is the logic. You can make use of f strings like how we did here, but I'm just writing a statement. But when you're really coding in the real time, it's always suggestible to use f strings like this. This gives the look of professionalism. So always use this. I am just using this for explanation purpose. Next up, we'll solve the composite number problem. So if you know how to solve if a number is prime, it is easy to solve if a number is composite. A number is called composite if it has more divisors other than 1 and itself, then it is a composite number. If we take an example, 4 is a example of composite number because the divisors are 1, 2 and 4. Other than 1 and itself, we have 2 also. That is why it is a composite number. So whereas if you understand about prime number, for prime number, it has to be like 1 and itself, then it is a prime number. This is simply the opposite of the prime number. So let's write the code for this. So first we'll write a condition where if number is less than 2, we have to return number is not a composite number. Otherwise we have to write a for loop. We have to check from 2 to the number. We have to start at 2 and we have to stop at the number. And for every number, we have to check if it is divisible by I. If it is yes, then it is a composite number. Number is a composite number. Otherwise, we have to return we can simply write this is a prime number. Number is a prime number. We are simply checking if there are any other devices. If there are any other devices other than 1 and itself, then it is a composite number. Otherwise, it is a prime number. Um, so we have already written code for abundant number. So we'll understand what is like if a number is hexagonal or if a number is triangular. A number is hexagonal if it can be expressed in this format, which is n into 2n minus 1. If we can express it like this, then it is a hexagonal number. So the quadratic formula is used to find the roots for the above equation. So we know that the quadratic formula is this: minus b plus or minus square root b square minus 4ac by 2a. So we use that formula and we'll get this equation for this expression. So we have to substitute the values in this particular equation. After substituting all the values, we get this formula. So we are using this formula. After finding this formula, if that number is an integer, then we can simply say it is a hexagonal number. Otherwise, it is not a hexagonal number. If you substitute all these values and find the equation, you will get this formula. You can check it by yourself. I have given all the steps in order to find this equation. If you want to do it manually by yourself, please do it. Otherwise, you can simply follow this and remember this particular formula. But it is always suggestible to understand how we got this particular equation. So we'll solve this. So for this, I will simply copy paste this this formula. Mm, So here we are using square root. So I will use math module. So for that we need to import math module. We'll import math math module. So if n is integer, if this n is integer, then we have to return number is a hexagonal number. Number is a hexagonal number. Otherwise, number is not a hexagonal. So we'll write else and we'll return not a hexagonal number. So in this way, we'll check if a number is hexagonal. In the same way, we'll check if a number is triangular. So for triangular, it has to satisfy this. Like if we can represent or express a number in this format, then it is a triangular. Again, we have to use the same formula as we discussed above, and we'll get this equation. And for this equation, we'll get the formula, this formula, and we need to check if we get integer. If this n is integer, then it is a triangular. Otherwise, it is not a triangular. So here, if we take example, 10 can be expressed in this equation as n into n plus 1 by 2. So it is a triangular number, whereas 11 is not a triangular number because we cannot express it in this format. So let's write the code. So we'll simply copy paste this. Again, we will be using math module here. We have to write math dot square root in this way, and we have to check if this n is integer. So this function simply checks if the number is integer or not. If it is integer, then we have to return as hexagonal. not hexagonal, triangular. Otherwise, we have to write else and we have to return not a triangular. So in this way, we have solved nearly 7 problems. Now let's check the output for each of the problem. We simply have to understand the equations and how to derive these equations for the last 2 problems, that is hexagonal and triangular. For the remaining programs, we have to understand how to find the sum of the proper divisions, proper divisors. And for the first one, we have to find if a number is divisible by 2, then it is even, otherwise odd. For leap year, we have to remember the 2 conditions, which is this and this. So let's run it and check the output. Okay, there is an error, line 69. There is an indentation error. Let's figure it out. The error is here. Okay, this is a method, but we are not writing any code here, so it is showing that error. We'll simply write it as pass. We're saying that it is an empty method. So we'll write first 12. 12 has to be even, and 12 is an abundant number, and 12 is a composite number. We know the formula for this is 12 composite number. Yes, because it has other divisors other than 1 and itself. And why is it abundant number? The proper divisor sum is 16, which is greater than number, so that is why it is an abundant number. So it is not hexagonal or triangular. uh, let's check for 10. 10 is a triangular number. We have seen already in the examples. We know that 10 is a triangular number. 10 is a triangular. Whereas we'll also check for hexagonal. 45 can be expressed in that equation. So 45 is hexagonal as well as triangular. 45 is a composite number too. It's a deficit number, not a leap year. 45 is odd. Yeah. Um, in this way, we have solved if else conditional based programs today. If you have not understand anything, please comment in the comment section. And you have to remember the fact that we are calling each method here. I have already written all the statements. That is why I have not written it explicitly. So I simply ran the code. Otherwise, I would have written each statement like this and I would have ran the code. So that's it for today. Thank you.